Are you ready?
It's time for Maths with Mr. Thomas.
Here we go, Chapter 2, Lesson number 7. Now we have covered everything in the fractions chapter. What I thought I would do is throw this lesson in here. I'm not really teaching anything as such, but I'm going to cover some of the past paper questions from the fractions chapter. So all of these questions will include content from the previous lessons. So make sure you have been over these lessons, make sure you're understanding your improper, your mixed number, proper fractions, adding, subtracting, multiplying, dividing, BIDMAS, and so on. Make sure you've been over that, make sure you understand it before you attempt these past paper questions. If there is anything that you come across that you're unsure with the past paper questions, look back to the individual lessons. If there's a multiplying question you're unsure of, look back to that lesson. I'll explain everything in a little more detail. But for now, let's move on and look at some of the fractions past paper questions. So this question here is from the 2022 past paper, and it's in paper 1, which means it's non-calculator. We have 2/3 bracket 1/5 plus 3/4. Notice how we have something in brackets, notice how we've got an addition, and we know from our really algebra chapter that if we have something right beside the brackets here, we're going to be multiplying the brackets by that. So it's really 2/3 times by this. Because there is more than one operation, there is a word that hopefully you are thinking of right now. Say it with me in the count of 3. 1, 2, 3. BIDMAS! Perfect! BIDMAS is the word that helps you remember the order to carry out these calculations. So, we're starting off with a B, which means we would do anything in brackets. First of all, the B is for brackets, so we do that first. Which means then, first of all, we will do 1/5 plus the 3/4. Which means then that this 2/3 will just stay as it is. And it's a bit in brackets that we're wanting to add. So 1/5 plus 3/4, in order to add fractions, what you need is the same denominator. Notice here you've got a 5 and here you've got a 4. Mamma mia! They're not the same. But in order to get the same denominator, is known as the lowest common denominator. You think about the 5 times table, 5, 10, 15, 20, 25, and so on. Think about your 4 times table, 4, 8, 12, 16, 20, 24, and so on, and find the smallest number that appears in both those times tables. What will it be? Good, 20 is in the 5 times table and the 4 times table. So we're wanting to change them both to something over 20 and something over 20. In order to change the 5 to 20, what do you multiply by? Good, you're multiplying that by 4, which means you would also multiply the 1 by 4 as well. So 1 times 4 gives us 4. In order to change from the 4 to a 20, what did we multiply that by? We multiplied that by 5, good, which means we would multiply the 3 by the 5 as well to get an equivalent fraction. So 3 times 5 is 15, good. So we've now got the 2/3 bracket, 4 20ths plus 15 20ths. Because the denominator inside the brackets is the same, they're both 20ths, it means you can do the 4 add the 15. And 4 add 15 is 19. So we've got the 2/3 bracket and then 19 20ths. Again, because we've got something just outside the brackets here, just imagine it with your 2 bracket. Let's say 3a add 5. What does it mean when you've got something right beside the brackets? What do? Good, you multiply, or it means the 2 times by what's inside the brackets. So when you have something just outside the brackets there, you multiply. So we've really got the 2/3 times by the 19 20ths. So now we've got this multiplication, and to multiply fractions, first of all you should see if you can simplify. Good. 2/3 doesn't simplify, 19 20ths doesn't simplify. Look at the 2 and the 20, can you divide them by the same thing? Yeah, you can divide them both by 2. 2 divided by 2 is 1, 20 divided by 2 is 10. The 19 and the 3, can you divide them by the same thing? Well, no, you can't. So you just leave that then. So really, rewriting this to make it a bit clearer, I've got a 1 in the top and a 3 in the bottom, and here I've got a 19 on the top and a 10 on the bottom. So these are what I'm wanting to multiply, and to multiply your fractions, really, you would just do the 1 times the 19 and the 3 times the 10, meaning you have an answer then of 19 30ths. And that there is the answer to that question. You got it? Well done. Question 2, the second past paper question. This is from the 2019 paper, paper 1, so it's again a non-calculator question. We've got 3/8 multiplied by 1 and 5/7. So, this time, Amar, what would you do first of all? Good. Change this mixed number into an improper fraction. So to do that, well, the 3/8 will just stay as it is, the times will stay as it is, but we'd have 1 times 7, which is 7, add on the 5, gives us 12, so that is the same as 12/7. So we've changed this mixed number to an improper fraction. We're now multiplying the two fractions into multiply fractions. First of all, see if you can simplify. 3/8 doesn't simplify. 12/7 doesn't simplify. You can't divide them both by the same thing. Diagonally across 3 and 7, you can't divide them by the same thing. But look, you've got the 12 and you've got the 8. You can divide them both by 2, or you can divide them both by 4. What would you divide them by? 4. Good, go for the bigger number. So divide the 8 by 4, and that gives you 2, and divide the 12 by 4, and that gives you 3. Once again, I'm going to rewrite that to make it a bit clearer. So I've got a 3 on the top, and I've now got a 2 on the bottom, and I've got a 3 on the top now, and then the 7 on the bottom. So I'm multiplying these two fractions together, and now I've simplified it. What do you then do? Good, multiply the numerators together, so 3 times 3, and multiply the denominators together, so 2 times 7. Meaning then, 3 times 3 is 9, 2 times 7 is 14, so 9/14 will be the answer. Woo! Question 3, third past paper question. This one is from the 2018 paper. Again, it's non-calculator. It's paper 1. I've got 2 1/3 plus 4/5. And what's the first thing that you notice? Yes, there is a mixed number, and when there's a mixed number, what do you want to change it to? An improper fraction. Good. So 2 times 3 is 6, add 1 is 7, so that will be 7/3. 2 times a 3, add 1 is 7, and just keep the denominator as it is. And then that plus 4/5 will stay as plus 4/5. I'm wanting to add these two fractions together, but bam, 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 the denominators are different. What you need is the denominator to be the same. So to get the lowest common denominator, think about your 3 times table and think about your 5 times table. What's the smallest answer that appears in the 3 times table and the 5 times table? Think about 3 times table, 3, 6, 9, 12, 15, 18, and so on. 5 times table, 5, 10, 15, 20, 25. Good, well done, you've got it. 15 is in the 3 times table and it's in the 5 times table. So what I'm doing is I'm changing the 3 to a 15, and to do that, what are you multiplying by? 3 times what is 15? Good, it's 3 times 5. So I also have to multiply the 7 by 5 as well. So 7 times 5 is 35. And over here, in order to go from 5 to 15, what do you multiply by? 3. Brilliant, you times by 3. So you would also do the 4 times 3 as well. And the 4 times 3 means that this number will be 12. So I've got 35/15 plus 12/15. Because the denominator is the same, it's just going to stay as it is. And how many 15ths do you have? 35 add on 12 is 47. Brilliant. Notice here, this is the improper fraction. The number at the top is bigger. And what we would then do is rewrite that as a mixed number. So 47 divided by 15. How many 15s are in 47? Well, start going up in 15s. You get 15, then another one will give you 30. Add on another 15 gives you 45. That was 3 15s make 45. So their whole number would be 3. And if you're up at 45, how many would you have left over from 47 to good? And because we're working with 15ths, it will stay as 15ths. So 3 and 2 15ths is the answer. Woo! Question number 4. Again, another past paper question. This time though, it's the specimen paper from 2018. Again, paper 1, non-calculator. 2 3/8 divided by 5/16. This time we're wanting to divide, but you'll notice here that again we've got a mixed number, and whenever you have a mixed number, it's best to rewrite that as an improper fraction, or a top-heavy fraction. So doing that, 2 times 8 is 16. Add on 3, 16 add 3 is 19, so that can be rewritten as 19/8. And we're wanting to divide it by the 5/16. In order to divide fractions, what do you do to divide fractions? Anybody help me out? Yes, Sophie. Brilliant, good. What you do is you take the fraction on the right and you turn it upside down. So instead of 5 at the top, 16 on the bottom, you end up with 16 on the top and 5 on the bottom. So you just flip it upside down. And when you do that, what happens to the divide? Good, it changes to multiply. That changes to a times. So we're now wanting to multiply these two fractions and to multiply two fractions together, multiply the numerators together and multiply the denominators together. However, if you do that, you'll get a really big number on the top and a big number on the bottom. So it's far easier to simplify. Good, you've remembered. So 19 and 8, can't divide them by the same thing. 16 and 5, you can't divide them by the same thing. 19 and 5 diagonally across, you can't divide them by the same thing, but the 16 and 8 you can with them. You can divide 16 and 8 by 2, or you can divide them both by 4, or you can divide them both by 8 even. Which one would you go for? The 2, the 4 or the 8? Perfect, go for the 8. Go for the biggest number you can. So 8 divided by 8 is 1. 16 divided by 8 is 2. I'm going to rewrite this once again. So that becomes 19 over 1, and then I'm multiplying that by the 2 over 5. I've simplified that now, so I just have to multiply the numerators together and multiply the denominators together. So 19 times 2 is 38, good, and 1 times 5 is 5, so 38 fifths will be our answer. However, notice the number at the top is bigger, bam, 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 and if you get that, you want to rewrite it as a mixed number. So, for the whole number part, how many 5s are in 38? In other words, what's 38 divided by 5? How many times will it go? Good, it goes 7 times. 5 times 7 is 35, meaning then your remainder from 38 will be 3. Good. And because we're working with fifths, we keep that then as 3 fifths. So 7 and 3 fifths is our answer. Woo! Next one, question 5. Another past paper question, this time from the 2016 paper, and it's a paper 1. We've got 3/4 bracket 1/3 plus 2/7. Notice here we've got something just outside the brackets. What does it mean if you've got something just outside the brackets? Good, it means you're going to be multiplying that. Again, think about brackets. If you've got a bracket, something, you're taking the a and you're multiplying it by everything inside. So we've got the 3/4 and we're multiplying that by what's in the brackets. However, we can actually work out what's in the brackets, and following the rules of BIDMAS, well, yes, we would do that first. B stands for brackets, and we'd work out what's in the brackets first of all. So we're wanting to work out this 1/3 plus the 2/7. So our 3/4 will just stay as it is. In order to add these two fractions inside the brackets together, we need the same denominator. So one of them is thirds and one of them is sevenths. Think about the 3 times table. Think about the 7 times table. So 3, 6, 9, 12, and so on. 7 times table, 7, 14, 21, 28. What's the smallest number that appears in both the 3 and the 7 times table? Brilliant, it is 21. Good. So, how do you change it from the 3 to 21? What do you multiply it by? Good, you're multiplying that by 7. So you'd also do the 1 times 7. Meaning then 1/3 is the same as 7/21. And with the 7 to 21, what do you multiply 7 by to get down to 21? Good, you multiply that by 3, which means then you also multiply the 2 by the 3 as well for our equivalent fraction. So 2 times 3 is 6, meaning that will be 6 over 21. So we've now got the 3/4 bracket, and we've got the 7 over 21 plus the 6 over 21. Because the denominator for them both is 21, it will stay as 21, and we just do 7 add 6. And 7 add 6 is? Brilliant, that's just 13. So we've got 3/4 bracket 13 over 21. Once again, whenever you've got something just outside the brackets, what does it mean you're doing with what's inside the brackets? Multiply! Good, so you're doing the 3/4 times by 13 over 21. To multiply fractions, see if you can simplify first of all. So 3/4 doesn't simplify, 13 over 21 doesn't simplify, but with 3 and 21, they both divide by 3. So 3 divided by 3 is 1, and 21 divided by 3 gives you 7. The 13 and 4, can you divide them by the same thing? No, you can't. So, rewriting this, I've now got a 1 at the top and a 4 on the bottom. And with the 13 over 21, well, that's now a 13 and a 7 on the bottom. I've simplified, so now all I do is multiply the numerators together and the denominators together. So 1 times 13 is 13. And in the bottom you would have, brilliant, 28 from the 4 times 7. So 13 over 28 is our answer. Woo! Let's try one more past paper question. This is question 6 and it's from the 2015 paper. Again, paper 1, non-calculator. 6 and 1/5 take away 2 and 1/3. Different ways of doing that, so if you're doing this a slightly different way and getting the same answer, that's absolutely fine. This is what I would do with this question. So, because I've got mixed numbers, I normally change them to improper fractions first of all. So 6 times 5, add on 1, gives me 31, so that is the same as 31 over 5. I'm subtracting the 2 and 1/3, so again put that as an improper fraction. 2 times 3 is 6, add on 1 gives you 7, so that's the same as 7/3. So rewrite them both as improper fractions. Now what I'm doing is I'm subtracting fractions, so I need the same denominator. To get the lowest common denominator, think about the 5 times table, 5, 10, 15, 20, 25, and so on. And the 3 times table, 3, 6, 9, 12, 15, and so on. The smallest number that appears in them both is, good, it's 15, fantastic. So what I'm doing is I'm changing the 5 to a 15, and I'm doing that by multiplying by, well, what do you multiply 5 by to get to 15? 3. Well done. So I would also do the 31 times 3 as well. 31 times 3 is, good, that's 93. With this fraction on the right, I've got the 3 and I want to change that into 15ths. So to change from thirds to 15ths, what do you multiply by? Good, 3 times 5 gives you 15. So I would also do the 7 times 5. And 7 times 5 is 35. Good. What you've done now is you've changed them both into 15ths. Woo! Thumbs up. So because they're both 15ths, it means you can now subtract the numerator. So you can do 93 take away 35, which gives you 58. From there, the number at the top is bigger. We've got a 58 on the top, we've got a 15 on the bottom, so it's an improper fraction. Whenever you get an improper fraction, rewrite it as a mixed number. So, to get the whole number part, think how many 15s will fit into 58. Well, if you count up in 15s, you get 15, then 30, then 45, then 60. Well, 60 is too much, so we're down at 45, which was 3 times. And what would we have a remainder of? Remember, 3 15s are 45. How many more do you have to add on to 58? Good, it'll be 13. And because we're working with 15ths, that will be 13 15ths. So 3 and 13 15ths is our answer. That is some of the past paper questions for the fractions chapter. Hopefully you're okay with them. You can try more in other past paper questions, or if you want a review exercise with everything from National 5 that you need to know about fractions, have a look at the TJ book, National 5, page 32, and the Remember exercise. Best of luck! Have fun. Enjoy. See ya. Turn it off.